Thank you for joining us for this live AImed webinar. My name's Alexis May. I'm Director of Content at AImed, and I'm pleased to be joined by an outstanding panel of experts today as we set out the basics of successful AI adoption in radiology workflows. First of all, we'll hear from Sanjay Parekh, Senior Market Analyst at Signify Research Limited, who will outline some of the key questions, key elements and best practices in terms of orchestrating the platform and AI app ecosystem. We'll then move to Dr. Felipe Campos Kitamura, practicing neurologist and head of innovation in diagnostic operations at DASA, who will share perspectives from the front line and tackle some of the challenges. Peter Eggleston, Director of Global Product Marketing Visualization Solutions at GE Healthcare, will then talk about GE's Edison Open AI Orchestrator before handing over to Florian Sarrazin, Global Product Marketing Director for Edison Ecosystem, who will cover the AI ecosystem and marketplace. Please feel free to use the questions tab on your control panel. We will have around 15 minutes for Q&A at the end of this session. Okay, without further ado, I'm going to hand over to Sanjay to get us started. Sanjay, over to you.
Great, thank you very much, Alexis, and hello to everyone joining us today. As Alexis mentioned, AI adoption in radiology workflows is going to be the area of focus, which I'm going to be talking about today. And I'm going to split this up into three parts. So I'm going to start off by looking at AI marketplaces and the role that they play before moving on to the central component of AI orchestration platforms, and then round off by giving a bit of context and background to AI developer platforms and how all three of these pieces are key to finalizing the puzzle of AI adoption in radiology. So before we jump in, I would just like to set the scene and talk about AI-based clinical applications for radiology. So here at Signify, we track this market really actively, and for us and generally, the market is seen as the tools that are encapsulated by detection, quantification, classification, and also AI tools which are on advanced visualization platforms that have AI capabilities or deep learning components to them. And so, as we can see from the graph, this market is growing, and in 2020, we estimate that this market is almost $350 million US. We see that again from the graph, the market starts to grow exponentially from 2023, and by 2025, the market we estimate will be $1.3 billion US. Now, some context around that. So what's the current state of play? Well, the market remains nascent, and it has been for a couple of years, but it's rapidly evolving. We've seen customer confidence growing, and despite a few suggestions of an AI winter, which is unlikely, AI is being increasingly adopted in radiology. However, for wide-scale adoption and true use of AI in radiology, more time is needed. So what's driving this market? New product launches. So algorithms are constantly coming to market. There was a high number of FDA approvals last year for AI algorithms, and this was despite the COVID-19 pandemic. We're also seeing a lot of launches of new products, say platforms from imaging IT vendors, and obviously these will be touched on throughout the talk. COVID-19 also highlighted the need for workflow efficiencies, and many of these AI tools also deliver these workflow efficiencies, improving the radiologist, automating tasks for the radiologist, such as routine tasks of measuring and looking at sizing of different pathologies. And finally, we've seen algorithms evolve. So from the initial point solutions that came to market, we now see AI being packaged into body area solutions, comprehensive, where they capture lots of different pathologies or detect lots of different pathologies, and also end-to-end solutions where AI vendors are looking beyond image analysis at the wider care pathway, for example, in stroke imaging. However, barriers still need to be knocked down, and we need more clinical validation studies to show the value of these algorithms in clinical practice. We also need more health economic studies highlighting the return on investment for these algorithms or these AI solutions. Reimbursement remains an issue, and I think will be one of the big factors that drive this market. And despite some notable exceptions, including the recent new technology add-on payment that was granted by the CMS in the USA last year, September, for stroke imaging solutions, there still remains a lack of reimbursement. And finally, regulatory approvals. So Asia lags far behind the US and the Europe in terms of the number of algorithms that have been approved for clinical use. And this is especially true in China, although that is a very nascent market that could grow quite rapidly. So that moves us on nicely into marketplaces and the role they have in terms of hosting lots of different AI applications for clinical deployment. We've seen marketplaces evolve, and initially the first wave of marketplaces or AI marketplaces was similar to App Store style solutions on your mobile phone, and they've now evolved to platform offerings. And I'll cover some of the differentiating factors as we go through the slide. We've seen these first wave of marketplaces being commercialized by third-party vendors, but increasingly, many of the imaging IT vendors now have their own marketplaces. And these marketplaces are not just for image analysis. Although they were set out to be for image analysis, there could be non-image analysis tools on this marketplace. And in addition to any native algorithms, the main bulk of the algorithms or applications hosted on the marketplace would be from third-party vendors. So what differentiates one marketplace from another? This would be the level of curation, for example. So what algorithms are hosted and whether they address whether one algorithm addresses one use case or marketplace has multiple algorithms addressing a single use case. The testing and the validation that the marketplace themselves does for the algorithms before they're deployed on the marketplace. Also, the level of support. Is the marketplace the first point of contact for customers, or are customers routed directly to the algorithm developer for any technical support? So those are key factors that could differentiate one marketplace from another. But this leads us nicely into the second part of this talk, which is AI orchestration platforms. And here, together with marketplaces, which enable the selection and purchase of AI algorithms, AI orchestration platforms address the last mile challenges of deployment, integration, and orchestration of all these AI applications within clinical practice. Primarily, imaging IT vendors are developing these AI orchestration platforms, and we've seen several launched to date, but we expect many more, including a number of launches at RSNA later this year. What approach do vendors take? Well, some vendors have gone down the route of creating an orchestration platform, which Dockerize multiple AI applications, whereas others have gone for the custom integration route, where different servers are needed for each of the AI applications, and I will come on to that shortly. However, regardless of the approach, it is these AI orchestration platforms that will truly enable radiology AI to scale. So as I mentioned, I'll just quickly touch upon this, where custom integrations require different servers or different nodes, as we can see in the blue boxes at the bottom half of the screen on the left. all feeding into the image management platform. But having an AI orchestration platform removes the need for each of these individual servers, where they can all plug onto a single orchestrator platform, and that can feed it directly into the image management platform. AI orchestration platforms also enable direct access to the diagnostic viewer, enabling the radiologist to interact with the results. And this leads us nicely onto other functions of AI orchestration platforms. So as I mentioned, a single point of integration is important. The routing of scans, so making sure the correct scan gets to the correct AI application. Supporting of AI inferencing, and also displaying the results for the radiologist to view in the diagnostic viewer. And some AI platforms even create a unified or user experience, removing the differences between different AI applications and creating a more seamless workflow for the radiologists. I'd like to highlight number 5 as one of the key areas of an orchestration platform that enables radiologists to interact with the AI. So this could be either through accepting or rejecting AI results, or even editing the results before they are committed to the PACS. Once the AI results go back to the PACS, they can be integrated in the work list and also triaged and prioritized based on the level of need. And this is also important for deploying the AI algorithms in terms of resource management, which can be carried out by the AI orchestration platform. Finally, AI orchestration platforms also enable the onboarding of many different algorithms from many different developers. And this leads me nicely onto the last part of my talk, which is AI developer platforms. Although these can be part of the orchestration platform, they're typically a separate platform delivered by some of the larger imaging informatics vendors. And what AI algorithm developer platforms set out to do is support both third-party developers, but also customers such as hospitals or large IDNs to develop and build their own AI applications for deployment in the clinical workflow. These platforms provide the resource and the toolkit needed to develop the applications, whether it is the processor or whether it is the large amounts of data needed to train the algorithm. They also provide a resource of testing the algorithms, so enabling the different algorithms that are built to be tested on external data sets to validate the algorithm. And finally, these platforms also provide a go-to-market route for algorithm developers looking to commercialize their solutions. So in summary, I've talked about the role of AI marketplaces, the importance in hosting, selecting and purchasing different AI applications. And as we know, the market's growing, so there's a rapid need for that to make it easier for hospitals to adopt AI. AI orchestration platforms, and the key for them in terms of addressing the last mile challenges of deployment, integration, and orchestration of these multiple AI applications, which will then truly allow medical imaging AI to truly scale within radiology. And finally, AI developer platforms, where this supports both hospitals and third-party developers to build and even commercialize their own applications. So thank you very much for that.
Thanks, Sanjay, for so clearly setting the context for this session. So we had a couple of questions in already. As mentioned, we'll go through those in the last 15 minutes or so of this session, so please do keep sending them through. Now though, I will say thanks to Sanjay and invite Felipe to present for us, please. Felipe.
Hello, everyone. First of all, I would like to thank AImed and GE for the invitation to talk here today. I'm Felipe Kitamura, and I'm currently the Head of Innovation in Diagnostic Operations at DASA, which is a diagnostic company. The largest diagnostic company in Latin America. I'm also a neuroradiologist at the University Hospital in São Paulo, and I'm going to talk today about the challenges in AI radiology workflows. These are my disclosures. I'm a speaker for GE and consultant for MD.AI. So to start, I would like to go back 4 years ago and see what the scenario looked like at that moment. At that time, DASA had just hired me and they wanted to use AI to improve efficiency and increase quality. And what we had seen at that moment is we didn't have as many AI companies offering products as we have today. So that was a very different scenario. If we wanted to have a specific algorithm to do a very specific task, maybe you would not find a company that would provide you with that. And then we had to develop a lot of things that we wanted to do. And the process of developing the models itself, which involves data extraction, anonymization, data curation, data annotation, and then the process of creating the models, the algorithms, model training, model validation, we went through all of those steps for some specific models. And people usually say, I usually hear, and you may have already heard that as well, that 80% of the effort to create an AI model is in data curation, and only 20% or so is related to model training. While I do think that's true, I think there is one more term in this equation, which refers to the integration part. And my reality at DASA was quite shocking when I tried to use those models in clinical practice. And we saw that model deployment was even more difficult than model development. So integration of models is something that takes a lot of time, a lot of effort to be done, especially if it's done in a way that is transparent to be used. And then after you start using a model, you have to monitor if the model keeps working as expected, and also continuously retraining the model if needed. So I'm talking about this because I see a lot of people worried about things that are important. For example, the ability of the model to generalize. This is something that is quite important. Bias, it's quite important. But if we only see those steps and get the best model ever, it doesn't help me if I can't use it in clinical practice. So the point I'm bringing here, we do have to worry about generalization, about bias and so forth, but we also have to worry about how we're going to deploy our models. And then this brings us to the second part of this talk, of my talk today, which is after all these years have passed and we have developed some models at DASA, we have deployed them, we have validated some of them, and we are monitoring them. Now we have a lot of vendors with products, AI products available. So the question is, shouldn't I just start using those products instead of developing my own or integrating my own? And the issue in having a separate contract with a lot of different vendors to deploy different models for you is that you think after you deploy hundreds or tens or hundreds of models, you're going to get something as organized as this picture in the left. But eventually what you get is something similar to the picture in the right. And of course, I know that model integration, AI deployment is not just plugging cables. We know that's not true, but I think the analogy still holds. And all the maintenance, all the IT infrastructure that is needed, if you have a separate infrastructure for each company you deal with, I think that's something that is not scalable. And I'm not even considering having a separate agreement and contract with each of these companies that provide those models. So this makes AI orchestration important. Whether you're going to build your own orchestration platform in-house, or if you're going to buy some off-the-shelf product, there are benefits and advantages and disadvantages to each of these. But the thing is, we do need an orchestration platform to coordinate all those models that are going to be used. And the last part of what I wanted to talk today is related to how actually the AI result changes the workflow of a radiologist. Me as a radiologist myself, I can see ways my workflow can change. And I brought here some scenarios that we can use as examples. So we start the day with the radiologist arriving at the hospital or at the radiology department to save the day. And then we sit down in our workstation, we start reading studies and reporting. And scenario number one, if I need a result from an AI model, I need to go to a separate workstation and process that study there and send the result back. And then I come back to my original workstation to keep reporting. And if I need another result, I have to do that over and over again over the day. We know that's something that is not good because it's very time consuming. I have to go to a different computer. We know some AI applications are deployed that way, and that's not the ideal scenario. Now, scenario number two, we arrive at the job, start reporting, and if we need an AI result, we have to open a separate application, a separate window, and logging into that application to have the result. While this is better than the first one, it still needs a lot more clicks than we're used to. And if you consider we're going to report tens of studies during a day, it's a lot more clicks than we should need. Now, scenario number three would be I'm using my workstation, I'm reading my report, and I have the result already integrated in my PACS. So that's fine, that's nice. But the result is shown in a way that I can't understand exactly what it means, or it's somehow not that easy to interpret. And this can lead to a problem, which is some radiologists may come up with the wrong diagnosis or understand the AI result in a wrong way, and that can generate problems or even wrong reports. So the way we show the AI result is also quite important, because that means people are going to be able to use that result in the best way possible. Now, the fourth scenario, we arrive at work, sit in our workstation, we open our PACS, the result is integrated, it's shown in a way that I can definitely understand in a clear manner. But then what? Let's say we have a model that tells me if that study specifically has a tumor or a hemorrhage or something else. Giving me that information doesn't exactly help me, because I still have to write the entire report and describe a lot of specific things about the disease that I found. So maybe that can reduce error by pointing out the major diagnosis in that study, but that's something that is not that helpful, because I still have to write the entire report. It doesn't help me save time. Now, the fifth scenario, now we have an AI model that helps me describe what I need to describe for that specific disease. But one more issue that can happen in integration is that if I have to ask for that AI result by clicking a button while I'm reporting, and if I have to wait a time for that study to be uploaded to the cloud, to be processed by the AI model, and then have the result back to help me write the report, maybe that's an issue that can happen, because sometimes networking is not that stable, especially in developing countries. Sometimes something can happen. This is one more step in the process. And so having a separate processing in the cloud, which should ensure that this processing is returned within reasonable time. So we won't spend a lot of time waiting for that result to come back. But if we have that solved and the AI helps me write the report, I think that's the best scenario ever. I know that's not going to happen for all models. I know that I'm being maybe too skeptical here, but I just wanted to bring the perfect scenario for a radiologist. And maybe the last possibility would be, I don't ask for AI results. I'm reporting the studies in my work list. And then I have an AI model finding some study in the past that has a critical finding. And this AI will nudge me to read that study next. And the reason I've shown this, I've shown Clippy here. This is an old Windows 95 app that used to nudge us in terms of what we should do. What we do want is to prioritize urgent cases. What we do not want is being interrupted all times with a lot of false positives. So this is something we have to take in mind when we're using these kinds of integrations that prioritize studies. So I have listed here which are the must-haves in terms of AI workflow, at least in my opinion. And I'm not saying I am telling all the truth here. Maybe you have a different experience in deploying AI in your institution, but what I found useful for me is AI must be easy to use. It must be transparent. I must see the result, and the result must be clear. It also must be timely. I must see the result exactly at the time I need that kind of information. So timely is also important here. It must bring value. It doesn't help to have a model that is easy to interpret, that is the result comes in a timely manner, but it doesn't bring any value for the patient or for the radiologist or for the referring physician or even for the company. So bringing value is something that is also important. And last but not least, AI should not disturb. So it shouldn't make my work process more difficult, and it should make us work better in an easier way. So those are the main must-haves I would say are important in AI deployment. I just wanted to bring one example here, which is a model that we deployed at DASA. This is a work that was done by our IT, our developers, and Marcelo Strauss, who is the radiology pediatrician at DASA. And what they have done here is the AI model gets all the hand and wrist X-rays from PACS, do the inference, and generates the report and have that report ready in our wrist. So when the radiologist is reporting, the report is already written there in the wrist, and we just copy and paste the report. Most of the times, the AI model gets it right, so it's just a matter of checking if it's right and copying and paste. But if the model is wrong, and sometimes it is, we have the equivalent of the Greulich Pile Atlas. We just scroll down to the next age, to the upper or lower age, and click that radiograph. We see the radiograph of the atlas there to compare. And then we have the new report generated. We just copy and paste. So this is the one example of model that we have deployed that have fulfilled most of the must-haves that I have shown before. So that's what I wanted to talk to you today. Now I'll hand it over to Alexis, and thank you again for the invitation to talk here.
Thanks, Felipe, for sharing your experience of going through those scenarios. Really useful. Great to see Clippy the paperclip again, I think. Moving on swiftly, I would now like to invite Peter to present. Peter, can we get you up on stage, please, as it were? Excellent.
Thanks, Alexi. I'd like to spend the next few minutes to show how ideas put forth by Drs. Parekh and Kitamura can be put into action. Specifically, I want to share with you the approach that GE Healthcare has used to seamlessly integrate AI into the radiologist workflow to allow you to work smarter, not harder. So at GE Healthcare, our goals are to help radiologists be more efficient, the reports more precise, and decrease the barriers to adoption of AI technologies. If you haven't been keeping up with the blinding pace of the development of AI-based clinical imaging applications, you might be unaware of some of the significant advantages that AI is providing today. So first, just a couple of examples that we've seen here at GE Healthcare with some of our partners. First, it can significantly reduce the amount of reading times for certain types of exams. For instance, radiologists using the clear read CT by Riverbrain technologies have seen an average of 26% improvement in chest CT X-ray reading time, chest CT reading time, and similar ones with X-ray. And users of ICA-Brain MS by Econometrics have experienced a 60% faster time on MS disease-specific reporting. Now, while these improvements are specific to certain types of exams and may only represent a small portion of your overall reading workflow, the extra minutes that they can save can add up substantially over the course of the day. They can also help screen your work list to help reduce the turnaround time on the critical exams, such as the ones coming from ED, trauma, etc. Second, many AI applications can increase your diagnostic precision and accuracy, delivering 20% or more increased precision. For instance, users of Riverbrain's Clear Read CT have been able to detect 29% of previously missed actionable nodules. But as radiology organizations adopt and deploy these into their imaging workflows, this will result in scores of AI applications all competing for limited resources such as computing power, cache, memory, and disk space, as well as the IT resources to install, configure, and maintain these scores of applications. And this is where GE Healthcare's approach can help reduce these burdens and overhead through a standardized, orchestrated approach that can significantly reduce your long-term cost of ownership. We do this through three key enablers: workflow for exam routing and resource control, automation of AI applied to the workflows, and a UX design that seamlessly integrates the AI into the radiologist reading workflow. In other words, we implement all the functional capabilities that an AI enabling platform needs to provide, as explained by Dr. Parak earlier in this presentation. We route scans to the appropriate AI algorithm. We control the AI inferencing, manage the computational resources to ensure critical studies are analyzed in a time-appropriate manner. We send the results back to the PAC work list for integration. We display the results in a diagnostic viewer, enable the radiologist to utilize the results, and most importantly, to keep up with the growing number of AI clinical applications being made available by supporting a rapid onboarding of the algorithms from many independent developers. So to execute on this concept, GE Healthcare created the Edison Open AI Orchestrator. It provides a visual method to instrument and optimize the imaging workflows, rules to manage the use of the AI applications, and an ability to triage and prioritize exams to provide a timely decision support. And currently, it is available as an optional component of the Centricity packs with Universal Viewer. Here's a quick workflow overview of how it works. So first, exams from the imaging scanners are sent into the packs. Their Edison OpenAI Orchestrator watches the exams coming into the packs and then runs rules on them based on the DICOM header information. It then matches the relevant exams with the proper AI clinical apps and routes the exams to these applications wherever they reside. It can be on-premise or in the cloud or a combination. And then in this case, if a non-contrast CT head exam arrives from a patient 18 years or older from the ED, it's routed to the MaxQ CHIPIO algorithm and given a high priority for processing. It then takes the AI results back to process them, passes them back into the packs. This orchestrated approach to AI workflow is made possible by our large Edison ecosystem of GE and third-party AI applications, which Florian will discuss in more detail following me. But by pre-integrating and validating these AI applications into the PACS workflow, it provides a significant advantage versus working separately with a multitude of vendors to integrate, configure, maintain each application, and thereby optimizing your IT resources and freeing them up for perhaps other more important activities. A less obvious but very important benefit of this approach is it allows you to also optimize your computing resources by enabling the sharing of virtual machines needed to execute each application. And to achieve this, the Edison OpenAI Orchestrator uses rules to determine the optimal sequence of AI processing and exams coming into the PACS and assigns them the computing resources they need. It also enables the system to quickly reallocate those resources when needed, such as an immediate processing of exams from ED, for instance, in the case of trauma or stroke. But from the clinician perspective, the user experience is really where our orchestration experience shines. It implements many of the ideal features that Dr. Kitamura had suggested. This is because our GE centricity packs seamlessly and uniformly integrates those AI results at the right points in a radiologist workflow, both in the work list and in the viewer, and can provide a clickless experience. So let's take a closer look at that. So what you're seeing here is the Centricity Packs Workflow Manager. It's an intelligent work list that is provided with our Diagnostic Radiology Packs viewer. The AI results are presented at the appropriate places in the workflow so they can be used to triage, prioritize the reading for an individual or group, and give more information on those cases. Starting on the left, we see that the available work list, and for each one of these, there's a number that shows the number of critical exam findings associated with them. The results can be used then to sort the exam list so that the ones with the critical findings are at the top. And any exam that has a critical finding is flagged. Hovering over that flag can quickly display the results to the reader. And the same holds true for any prior exams that might have critical findings based on AI. And finally, in our diagnostic hub, along with the exam notes, the radiologist can see any report provided by the AI algorithms that have been run in the exam. Now, the important things to note in this example are that we're enhancing the radiologist workflow, not changing it. And there are no additional interfaces or workflows that the radiologist is required to learn or use. And most importantly, we haven't added any additional clicks to the radiologist workflow. So next, when the radiologist opens a case to read, the AI findings can be automatically displayed as part of the hanging protocols. They may be hidden until such time as the radiologist wants to view them. They're presented in the exam history and can be viewed along with the current study. And in this example, we're seeing that the icometrics IcoBrain traumatic brain injury algorithm return a finding of acute ICH. It provides a summary report as well as color-coded areas where the abnormalities were detected, boundaries of lesions, quantitative measurements such as lesion diameter, volumes, and so forth. And these could be used by the radiologist to rapidly populate its reports. So the bottom line is this approach is a platform approach, and it's enabled by a flexible and open orchestration engine. It can facilitate seamless integration of AI-based clinical applications without requiring you to change your current workflows. It allows easy onboarding of existing or new applications from multiple vendors. It provides rapid and robust scalability. It provides a uniform interface and experience across multiple AI-based applications. And as I stated earlier, most importantly, it does not add any additional clicks for the radiologist. But without a wide variety of AI applications, a platform such as the Edison OpenAI Orchestrator would not have any value. So up next, Florian will demonstrate how the GE Healthcare is addressing this need through our Edison developer ecosystem and marketplace. Thank you.
Excellent. Thanks, Peter. As you mentioned, we will now segue seamlessly into Florian's presentation. Florian.
Thank you, Alexis. Hi, everyone. Thank you for joining the webinar. So Pete shared the value of the orchestrator to seamlessly integrate the application into existing workflows. So for this last presentation, I will zoom back out on the overall value of the platform ecosystem. So as introduced at first by Dr. Parekh in his first presentation. So I will be sharing the value of the Edison ecosystem that include the three components: marketplace, developer program, and orchestration software, the Edison OpenAI Orchestrator that Pete just shared. So we have now numerous examples on how artificial intelligence can help as you, as healthcare provider, work to improve efficiency and quality of care. And this was illustrated in the presentation of Dr. Kitamura and Pete Eggleston. So with applications that can help for triaging, decision support, assisted reading, and structured reporting. So we all know now that there is AI can offer this opportunity for radiologists to improve efficiency and care. And in fact, if we look at the market today, the wave of AI is already underway. This has been illustrated also by Dr. Parekh in the first presentation, we see on the left side that more than 80% of healthcare provider leaders are seeing value in implementing AI application in healthcare. And if we look on the industry side, we see more than 190 startups and software companies that are already developing imaging AI applications. So those software companies, they are not usually developing one application. They are developing 2, 3, 4, or more applications. So meaning that's very good news. We have hundreds of applications that are coming to market to help healthcare provider improve outcomes. But here is a challenge. Oh, yeah, here is a challenge. Sorry for that. Here's a challenge that was expressed also by Dr. Kitamura is healthcare provider will face a challenge by risking crushing their team with the time required to find, to assess, to buy, to implement multiple algorithms from multiple vendors. And if we look even at the purchasing side, so the purchasing process that today healthcare providers follow for software or modality acquisition, so it's a large number of steps from the time you set up a purchasing committee to the acquisition and finally to the deployment and the adoption of the software or application. It can take months. And this approach just cannot work if we think of dozens of applications that you might be deploying in the coming years. So there is really the need to shift to an ecosystem approach with a simple way to find, try, buy, and finally implement all the application healthcare provider needs from a single partner, a single ecosystem. So that's really the value of what we call the Edison ecosystem. So there is several components. There is a marketplace to make it easy for healthcare provider to browse and find all the applications that are available on the ecosystem. There is an orchestration software, the Edison OpenAI Orchestrator, that will enable seamless integration of application into existing workflows, what Pete presented just before. And applications that are from GE Healthcare and from others. So link to the developer program to include this innovation. I will touch more about that in my next slide. And all of that with a single IT implementation partner, purchasing partner, and invoices. So single point of contact for all of that. It means that you don't have to go to every single startups or every software companies, create a new project, adding a new vendor, planning a completely new IT project for every new application you want to add, you want to use. And of course, I was mentioning the developer program. We as GE cannot develop all those applications that you need ourselves. So really through our Edison developer program, we are assessing and integrating application from independent software vendors, startups, to bring to healthcare provider a curated selection of application. So how does it work? The process is simple. We have startup innovators that are signing up on our program, and then the GE team will analyze the application and its value to make a go, no go decision for the integration. If we have a go, then our product team will integrate, test the application, and finally we will distribute it. So we are not simply adding any new vendors on our marketplace. We are carefully assessing and vetting those applications to provide a curated selection of applications. Which brings me to my next part, and I will be sharing my screen for this one, is the marketplace. So where can I find all those applications? Sorry for the technical challenge. So the marketplace is a web page that is accessible on apps.gehealthcare.com. So you can all access it if you connect on this address. And you see it right here. It's a list of applications that are available on our ecosystem. So you can narrow down easily the research. You have a search button here, but you can also narrow down your research with some filter on medical specialty, product family, country, or anatomy. So if we think of AI applications that are compatible with the Edison OpenAI Orchestrator, you can filter here on product family on Edison OpenAI Orchestrator. Country, for example, I am in the US. I want to see what's available in my country. And here you can see all the application available, AI application and compatible with our Edison OpenAI Orchestrator software. Then if you want to learn more on a specific application, you click on learn more and you arrive on the detail of the marketplace listing, which give you a little more information on this application. So you have more detail on this application. So this application is critical care switch, which is a chest X-ray application that's helpful for the detection of pneumothorax, so triage case for pneumothorax on chest X-ray. You have more information that you can download directly on the marketplace, like brochure, data sheet right here. If you want to be in contact with the GE representative to have more information about the application, a demo, pricing, to understand how it integrates, you can fill in a form right here and you will be in contact with a GE representative or subject matter expert for more information. For this specific application, we also have an online demo that is available directly on the marketplace. So if you click on it here, you will arrive on this page, and if you create a login and a password, then you will log in on the online demo system that we have available for this algorithm. Just give me one more second. When you arrive on this system, so you will be able to load your own cases of chest X-ray to test the algorithm directly. Unfortunately, it's not working right now. So the bottom line is you can either test and demo with demo cases on the application, or you can directly upload one of your chest X-ray examination and start the inferencing with the algorithm and test the result of the algorithm with real cases. All right, so again, the address is apps.gehealthcare.com if you want to connect and learn more about all those applications. I will stop sharing my screen and all right. Thank you. So just as a conclusion on the Edison ecosystem, so really, if in one sentence, the ecosystem is designed to help healthcare provider to help you improve efficiency and quality of care by making it easy to access a large selection of AI applications. Thank you all. Thank you, Alexis. Back to you.
Thanks, Florian. That was great. Thanks, everybody, for some great talks. We've got about 13 minutes now to go through questions. Just before we get started on that, we've got some poll questions, which I would love the audience to answer, which I'm going to launch now. It's just to give us a sense of how you rate the event. Additionally, there's a couple of other ones that we're going to put out throughout the next segment. So indeed, you can see that as we go. So what I'm going to ask is for all our excellent panelists to join us, and we can go through this sort of discussion segment. We've got some good questions coming in. Can everyone get their cameras on so we can see all of you? Lovely. Thanks everyone very much. So just to start with, I have a question. How do you see the expansion to encourage earlier diagnosis of the major causes of our most widely and costliest diseases in terms of heart attacks and strokes? Did anyone want to come in on that one first of all? Who wants to have a go at that?
Sure, happy to jump in here. So, of course, that's quite a complex question and maybe even multifactorial. But one of the things here is obviously prioritization for critical care cases such as stroke. So obviously you need to get the image to the right algorithm as fast as possible and then get the results back to the radiologist and the wider clinical care team to ensure that treatment happens as soon as possible. As we all know, with stroke, time equals brain. However, if we take heart attacks happen quite suddenly and abruptly. At the moment, we don't see many, if any, AI applications to detect heart attacks. However, there are a number of AI applications which detect indicators or likely signs that heart disease is happening, such as coronary stenosis or calcium buildup in the coronary arteries. And these solutions obviously need to still be seamlessly integrated within the workflow, delivering the results to the radiologists to help them make better decisions, but maybe not prioritized in the same manner and extent to, say, a stroke imaging case. And this is where orchestration platforms have the ability to do this, and also then give the radiologist the chance to look at the results and make sure the correct diagnosis is being determined, and also the cases are being triaged and prioritized accordingly.
Thanks, Sanjay. While we've got you on the lectern, as it were, we have a couple of questions about the kind of how you measure the size of the market and the kind of perspective on that, including how you see the AI marketplace growing from bottom up to top or top down, to be able to meet the sort of the most major portions of the marketplace. If you could share your views on that, and other panelists, if you have any views you want to share on that also, please do come in.
Sure. So with regards to the first part of the question, of course, that's not the focus of the talk, but I'll quickly touch on it, that we speak to all the vendors. We look at who has commercially available AI algorithms that are deployed in clinical practice at the moment. And through there, we through dialogues and measuring up the number of installs, we estimate the market size. Of course, I'm happy to discuss this offline or on another forum. But coming back to the focus of orchestration platforms, marketplaces, etc., I think it's very hard to have a top-down approach at the moment. The number of use cases or commercially available algorithms on the market today is very small compared to all the tasks that a radiologist performs in their day-to-day workflow. So we can't really say a top-down approach will happen. But from the bottom up, we've started to see different marketplaces, different orchestration platforms trying to, as the other speakers have mentioned as well, curate, so get the best application for that particular use case for that company's or that vendor's install base. And that way, you can get different applications for different use cases, addressing a wide breadth of the radiology tasks that they have to do as more and more AI applications are commercialized, receive regulatory approval, and come to market. So I'm sure someone else, they'll have other things to add, but I think it's more of a bottom-up curated approach that marketplaces and platforms are going through.
Marianne, I see you nodding. Do you want to come in?
Sure, yeah, I can comment on the G strategy for the marketplace and our developer program. So which vendor we decide to integrate with. So we are, of course, going by the use case first. So G doesn't decide which use case we are targeting. We look at the market and the need from the customer, and then we try to target developers, startup innovators that are playing with on this field. And the last piece is we are not looking to have only one application per use cases. We want to give the choice also to the customer to choose between an application A, B, and C. So really that's those two aspects, bottom up from the use cases, and also giving not only wide choice but several choice of applications.
Thanks, Florian. Just to mention that we're going to be putting out a couple of other polls, so look out from them. We've just got another question through from Timo de Bont on clinical trials. Medical physicists will need to validate the outcomes of AI apps in the local clinical environment. How this will be done is food for thought. Does the Edison ecosystem support the conducting of a virtual clinical trial by uploading local data and running the app? That's the questions. But to you, Florian, do you have a response to that, please?
So the way today you can still hear me, right? Yep. Okay.
Yes, we can still hear you.
Thank you. So the way we integrate the application and the selection we are doing on the application, we need a regulatory approval. So that's one of the major bar for a commercial partnership to be listed on the marketplace. The question from the attendees was clinical trial to validate the outcome. So we work with the third-party application as part of the selection and analysis and identification during the developer program process to see if we integrate this application or not, and we take into account those clinical studies, those peer-reviewed publication, to basically make a decision if we integrate this application, yes or no. Are we managing this clinical trial on behalf or facilitating this clinical trial on behalf of the third party? That's not something that GE does today.
Thanks, Florian. It's just a few minutes left. Do keep the questions coming in, but I wanted to ask the panel a broader question just to as we head towards the end of this great session. And it's about COVID and kind of implications. So obviously the pandemic has been impacting the healthcare system across the world. And for all of you, what's your perspective on how COVID has been influencing sort of digital and AI transformation in healthcare? Anyone want to come in on that first? I'm sure you've all got your thoughts. Felipe.
Yeah, if I may chime in here. So my view is a little bit biased in terms of what I have seen, because I've seen what happened in the Brazilian market. But I guess the same thing may have happened around the globe as well. What we have seen here is mostly a call for action from a lot of people, and I think we have evolved a lot of telemedicine in general. Teleradiology was already here, but telemedicine and a lot of the digital transformation processes took place during the pandemic, and I think that was one of the causes of this process to be accelerated.
I'm happy to comment as well on. Oh, sorry, Alex. I'm happy to comment as well and continue on what Dr. Kitamura said. We also feel that COVID underscored something that we already know in the healthcare space, which is the volume pressure, the quality pressure that was exacerbated and intensified during COVID. And so we need to do things more efficiently, which AI plays a huge role in, and that's already in high demand during COVID. So I think we are going to see this continued demand on even after COVID, which underlines something much more important, is AI is not about the technology, but about the outcome it's provide. And if we look on the macro level, we also have seen an acceleration of digital transformation with more cloud adoption, virtual care, and telemedicine. And so the bottom line is I'm encouraged by the trend of digital transformation acceleration, but I'm even more aware or reminded of the need of technology for a purpose, for true outcome around efficiency and quality of care. So I'm sure we are gonna continue seeing that focus around outcome as we come out of COVID.
Thanks, Florian. Sanjay, from the kind of analyst perspective, does your research, your work, does that kind of support what our fellow panelists are seeing happening on the ground, both within clinical practice and on the industry side?
Yeah, thanks for that, Alexis. And yes, so I agree with both Dr. Kitamura and Florian as well. What we see is, yes, technology is being increasingly adopted, and customers are healthcare providers are turning to AI. But obviously, there's a caveat here where workflow efficiencies, customers or hospitals have started to realize that there's a need for workflow efficiencies. However, because of the COVID pandemic, focus was shifted from technologies in the early part of 2020 to just treating and dealing with the impact of the pandemic. However, as we moved out of the first wave, hospitals then started to look at ways to speed up and deal with the backlog of patients, especially in radiology. And that's where the AI and the technologies have come in. So even though there was that initial impact, we've started to see technology being adopted to help speed up the process. And then again, as Florian has mentioned, there's been a big shift because vendors can't go to the hospital for sales meetings or for in-person contact. There has been that shift to cloud deployment, more openness from a lot of hospitals or even countries that were resistant to cloud adoption. Many of them are now opening up and looking at cloud adoption and different ways of deploying solutions such as AI, but also other digital technologies within their workflow to make it more efficient and more cost effective for both themselves as the vendor, but also the customer, the healthcare provider too.
Thanks, Sanjay. It looks like we're at time. So thank you so much, gentlemen, for your participation today, and thanks everyone who has attended and for your questions, participating in the polls, to GE Healthcare, and yeah, everyone out there. We hope this has been a valuable and insightful session. As I mentioned earlier, it will be available to view on demand at ai-med.io. For now, I've been Alexis May for AImed. We look forward to welcoming you to the next in our series of AImed live webinars. Thanks again to my panel, and we'll see you very soon.
Thank you.
Thank you.
Thank you.